The order of operations, rules of the road. When I was a kid, I wondered how two cars at a four-way stop knew when to go. Was it just a game of chicken? Was there some magical telepathic link between drivers? Of course, when I got older, I realized there were rules for that sort of thing. In order to know when to stop and when to go at an intersection, you have to learn the rules of the road. Math is the same way. The order of operations is a set of rules that tells us when to complete which operations if we want to correctly evaluate an expression. If we want to find the correct value of the expression 4 minus 9 plus 6 times 5 divided by 3, we need to perform the addition, subtraction, multiplication, and division in a specific order. There are actual mathematical reasons behind the order of operations. But right now, we just need to learn the rules and how to apply them. Trust me, this is going to come up all the time, so you'll want to get confident and comfortable with it. An easy way to remember the order of operations is with the mnemonic device PEMDAS. P stands for parentheses, but this first step includes any symbol that groups terms. E is for exponents, M is for multiplication, D is for division, A is for addition, and you guessed it, S is for subtraction. I know PEMDAS isn't a real word and may be difficult to remember at first, so think of it as, please excuse my dear Aunt Sally. I don't know what Aunt Sally did, but if she's helping us remember the order of operations, I'm sure it's worth forgiving. PEMDAS is the order we follow when an expression contains multiple operations. Let's put a more complex expression up on the board so we can see this in action. 14 plus 5 minus 2 plus 3 times 2. There's a lot going on there, but don't worry, it won't look so scary in a minute. According to PEMDAS, we need to look at parentheses and other grouping symbols, such as brackets, braces, and radical signs first. In this case, we have two sets of grouping symbols, so what do? We're going to peel this expression like an onion until we get to the innermost group, 2 plus 3 times 2. Since there are no additional grouping symbols, it's time to look at the next operation, E for exponents. None of those here, so we'll move on to M for multiplication. According to the order of operations, our next step is to multiply 3 times 2. We'll put the result back into the parentheses where 3 times 2 used to be, so now our innermost parentheses is 2 plus 6. Since there's only one operation left here, we'll go ahead and add 2 plus 6 to get 8. Now that we've solved our parentheses, we can work outwards and look at the next grouping symbol. In braces, we have 5 minus 8. Once again, there's only one operation inside the group, so we'll go ahead and subtract 8 from 5 for a result of negative 3. Our final operation is 14 plus negative 3, or 14 minus 3. Following the order of operations, we've reached a final answer of 11. The order of operations works for fractions too. Just remember to evaluate the numerator first, then the denominator, top then bottom. Don't forget to simplify the result. Fraction bars are actually considered a grouping symbol that falls under the parentheses category. Absolute value bars are also grouping symbols that would be evaluated in the parentheses step. What if you run into a complex exponent? Good news, the order of operations works there too. If we have 3 with an exponent of 2 plus 3 times 2, we evaluate the exponent first by multiplying 3 times 2 equals 6 first, then adding 2 plus 6 equals 8. Now we have 3 to the 8, and we can complete that operation for a final answer of 6,561. Now that we've talked about groups and exponents, let's talk about multiplication and division. That's right, I said and. Multiplication doesn't always come first. If you have both multiplication and division in an expression, you perform them from left to right as they appear in the expression. The same rule applies to addition and subtraction. They happen at the same time, from left to right as they appear in the expression. But PEMDAS says multiplication and addition first, you may say. That's because please excuse dear my Sally aunt doesn't make sense. Trust me. Left to right, perform multiplication and division in the same step, then addition and subtraction in the same step from left to right. Let's look at another example to illustrate this. 40 divided by 5 minus 3 times 2 plus 24 divided by 8. We don't have any parentheses or groups, and we don't have any exponents, so this time we're skipping straight to multiplication and division. I'll walk through the expression and circle all the operations we should be completing during this step. We'll start at the far left. The first thing we see is 40 divided by 5. It's not multiplication, but multiplication and division are a combined step, so we'll circle it. Next we see 5 minus 3, but we're not there yet in the order of operations, so we'll move on. Next is 3 times 2. Circle it. Then 2 plus 24. Skip it. 24 divided by 8. Circle. 40 divided by 5 equals 8. 3 times 2 equals 6. 24 divided by 8 equals 3. Now the expression looks very different. Going into our addition and subtraction step, we're left with 8 minus 6 plus 3. We're on the last step, and we'll complete the remaining operations from left to right, just like we did with our previous step. 8 minus 6 is 2, and 2 plus 3 is 5. 5 is our final answer. Congratulations! You now understand the basic rules of the road for mathematical expressions. If you need more help understanding the order of operations, check out our order of operations examples video.